Hello everyone. I am here today to talk to you about equations. We have just finished up a unit on expressions, and now we're moving into a new unit on equations and inequalities. So for the first couple of weeks or so, we're going to talk about equations. And we're going to start simple and work our way up to some more difficult ones. So what you see here today is we're going to focus on equations that contain addition and subtraction. We will get into some that have multiplication and division. Then we'll get into what is called two-step equations, multi-step, and some where they have variables on both sides. So it will continue to get more difficult here, but today is just the beginning. And an equation looks similar to what you see here on my page. In this one, it says n plus 1 is 3, right? So an equation has an unknown value in it. And our goal of an equation is to determine what this unknown value represents to make this statement true. Now, I know you can look at this one and figure it out in your head, but this is just a beginning here, okay? So be patient with me. So this one says n plus 1 is 3. Okay? Now, in an equation, one of your goals is that both sides of the equal sign need to represent the same amount. So for example, here's my equal sign. So to the left, this needs to equal what is on the right for an equation to be in balance. And that is important for your equation to be balanced. They both have to have the same amount. Think of a scale here, right? When you put items on a scale, both sides of that scale have to have an equal amount in order for them to be balanced. So let's say that this scale over here on the right, okay? If I'm going to put some weights on it, okay? So on this right-hand side, this is 2 pounds, and so is this 2 pounds. So I have a total of 6. For a scale to be balanced, I need to have a total of 6 over here. It doesn't matter what it looks like. I don't have to have the exact same numbers on the right, meaning I don't have to use 2s, right? I can use 1 pounds as long as they total 6. So as long as I have 6 on both sides, my balance is equal. This is 6 pounds, even though it used 2 pounds each. And this is 6 pounds, even though it used 1 pound each. Well, the same thing applies over here. Yes, this totals 3, but my left side also needs to total 3. And it can look like 1 plus 1 plus 1, or it could be 2 plus 1, right? As long as both sides are equal, it doesn't matter what it looks like, as long as they're both the same amount. So when we are solving equations, both sides need to equal the same amount. Now, I know most of you can look at this problem and say, well, n has to be 2 in order for both sides to be equal. And you are right, okay? But there is a procedure that we must use to solve equations. And this will come in handy as they keep getting larger and larger. So I'm going to be a little bit of a stickler about this in that we have to be writing things down and solving them. We're not doing this in our head. Okay, it will pay off for you as they continue to get harder. But when we solve an equation, what we really want to do is we want to leave our variable on the left side, and we want to get rid of everything else on that left side of your equal sign. Okay? Think of it almost as if there is a line that is going from your equal side down. And this is your left side, and this is your right side. Okay? So we want to get rid of this plus 1 here. We just want to be left with an n. We want to be left with our variable on the left. Okay? So we can't just totally get rid of it. We've got to move it and we've got to rearrange our problem. So to solve this, what we are going to do is we want to move this 1 from here to the other side. And to do that, we have to use the opposite operation. So this says n plus 1. So to get rid of 1 or to move 1, we need to use the opposite. So the opposite of adding 1 is to subtract 1. Right? That would get rid of it, because think of what this means. If you have plus 1 and now you're getting rid of 1, this is now a 0. So in reality, this is gone. Okay? But in an equation, as we said, what you do to one side, you have to have done to the other. So again, think of this as your sign. If I subtract 1 from this side, I also need to subtract 1 from this side. Okay? I've done the same thing to both sides of my equal sign. So now let's look at what we have left. Well, as we said, plus 1 minus 1 equals 0. So really this is gone. So the only thing on the left is my n. And the only thing on the right, the equal sign is still there, but this is 3 minus 1. And we get a 2. So we have shown that n is equal to 2 in this problem. Okay, and we did it by using the opposite operation. Okay, now as I said, I know most of you can do this in your head, but you need to be able to write the opposite operation here and to solve. I'm going to be a stickler for this. Okay, let's look at another one. Okay, let's look at this one. This one says n plus 12 is 23. So our goal, we need to figure out what n is to make both sides of the equal sign equal. So again, think of this as sort of the left side versus the right side. I'm going to draw a line through my equal sign. Okay, we want to isolate this variable. We want to get the variable all by itself. So that means I need to get rid of 12. If you have 12 things, to get rid of it, you would need to do the opposite or subtract 12. That gets rid of the 12, right? Because think about what that says. That says if you have 12 and I subtract 12, now I'm at 0. So this is actually gone, right? When you subtract 12, you're gone. So the only thing on the left is n. And again, I must do the same thing to both sides. So if I subtracted 12 here, I have to subtract 12 here. So the problem on the right we're left with is 23 minus 12, right? And we would know that n is equal to 11. And really, if you plug 11 in here, you would know that you got this right. We use the opposite operation. Opposite operation. Okay? Okay, let's look at this one. This equation says n minus 9 is 16. So we need to figure out what does n represent to make this equal 16. All right, so this one's a little different because this one is subtraction. Not much, but a little bit. So again, the left side of our equal sign and the right side must equal the same thing. They need to balance. So we still want to get rid of 9. Okay, we're going to move it sort of over to this side. We want the n by itself. So think of this. The opposite of subtracting 9, the opposite operation would be to add 9. Right? Think about it. If you're subtracting 9 and then we add 9, right, that would equal 0. So that eliminates this. It is gone. We've gotten the n by itself on the left. So we need to do the same thing to the right side of the equal sign. So if we added 9 here, I need to add 9 here. Right? This is gone. I have an n. So on the right, it is just 16 plus 9. And if we add them together, we would see that n is 25. Okay? And again, if I plug 25 in here and subtract, I would get 16. So we're just using the opposite operation. Okay? So far we've been doing this and everything has been positive numbers. Now let's plug in some negatives. Okay, I have two problems on this page. They're both addition. Okay? We'll start with the one on the left. This one says n plus a negative 4 is 5. So just because there's a negative in here, we're not going to change how we have solved these. The equal sign is still your middle, and what we do to the left, we must do to the right. And we're still going to use the opposite operation. Okay? So we need to figure out what n is that when added to negative 4 gives us 5. So we are going to use the opposite operation. It is showing us addition, so the opposite is subtraction. Okay? Do not change the value of this number. Sometimes people think they have to change this to its opposite too. No, just change the operation. So we are going to subtract a negative 4. That's the opposite. The only thing that has changed is we're using the opposite operation to move it over to the right. That's it. Okay? So now again, what we do here, we have to do over here. So minus a negative 4 happens on the right also. So think about what this means. This is actually equal to 0 again, but let's think. So if you have negative 4 and I am subtracting a negative 4, right? So we would do leave, change, opposite. So again, this is equal to 0. So it is gone, right? There's nothing left here. So the n is still left. It's over here by itself. That's what we wanted. And if we go over here, my problem is 5 minus a negative 4. So leave, change, opposite, we get 9. And think, if I plug a 9 in here, 9 plus negative 4, yes, that gives me a 5. Okay? So again, only thing we're using is the opposite operation. Everything else stays. Don't change your negative signs. Let's look to the right. I'm sort of going to draw a line here. Okay? N plus 7 is a negative 11. So there's our negative again. Okay, so here's our equal sign, where what we do to the left, we have to do to the right to make everything balance. Okay, so if we have a positive 7, the opposite is to subtract 7. We want n over here by itself. And think, if you have 7, the opposite is to subtract 7. That would be 0. So this is canceled out. It is gone. You have an n over here. What was I doing? I was subtracting 7, so I'm going to subtract 7 here. So the problem is negative 11 minus 7. Subtraction, so I do a leave, change, opposite, right? So you would get a negative 18. And if I plug negative 18 in there to double check myself, yes, I get a negative 11. Okay, let's look at one more set. We did addition this time. Let's do some subtraction with negatives. Okay, so last set here. These are subtraction problems, as you can see, and they involve negatives. Okay, so again, we're not changing how we do this. The equal sign here is going to be our sort of halfway point. What we do to the left, we have to do to the right. That's why I sort of draw a line down through it as a reminder. We want the n alone. So we've got to get rid of this. Okay? Now, the opposite of subtraction is addition, right? And then we have the -6. That is not changing, just the operation. So what I do here, I must do here. Okay? Again, let's think. This is now gone. It equals 0. So I have an n on the left. And on the right, my problem is 9 plus a -6. And 9 plus a -6 is 3. If I plug this in here, 3 minus -6, leave change opposite, it's 9. Okay? Now, one other thing I want to show you is sometimes people want to get rid of the subtraction. If you are somebody who likes to get rid of that right away, what you could do is you could change this to addition right away, and we'll still get the same answer. So let me just show you this quickly. So subtraction, really, we can add the opposite here. So if we do leave change opposite right away, right? Now my opposite is minus a +6, or just -6. And so -6 would be here, and I still get 3. N is equal to 3. So either way, you can keep it as subtraction, you can change it if that's what you like to do. Totally up to you. Both ways will work. All right, last one. Here's my equal sign. What I do to the left, I have to do to the right. Okay? I want n alone, so that means I have to sort of get rid of 8 by moving it to this side, the other side of the equal sign. We do that by using the opposite operation. So this one says subtracting 8. The opposite is to add 8. Right? Think of what that means. If you have -8 and then +8 equals 0, right? They cancel each other out. So I'm going to do the same thing here. If I'm adding 8, I'm going to add 8 here. So what do I have left? Because this is gone, it's 0. You have n left on the left, and on the right, -14 plus 8. Using your integer rules, you would get a -6. And again, if you plug that in, leave change opposite, you would get -14. Okay guys, so that pretty much sums up solving addition and subtraction equations. Couple of key things. Remember, your goal is to isolate the variable, meaning you want to get it by itself on the left. And to do that, we use the opposite operation, and both sides of the equal sign must balance. So what we do to one side, you do to the other. So you're going to have some problems on your Schoology assignment today that look like this. And I have put 2 lines underneath for you for now, just to sort of force you to do this. As I said, I'm going to be a stickler. You have to show me your opposite operations. Okay, it's going to be something a habit you need to get into as we keep getting harder and harder here. So for example, I would say, okay, my opposite operation on my first line is adding, and then the -5 stays, right? And what I do to the left, I have to do over here. So yes, you are writing this twice. Okay? If you like to draw the line through like I did, go right ahead. That works for you. Okay? You know that crosses this out, and so I just need to solve this over here on the left. So the problem is -7 minus -5, or +7. Leave change opposite. This would be 12, and you'll put that n is 12. So you're going to fill this out and fill this out for me on your assignment today. Okay? So good luck with this. We'll go over it when I see you. I promise we'll go over this. And then we'll add in some multiplication and division before we get bigger. But we're just doing addition and subtraction today. Okay? Good luck on the assignment. If you need me, please send me a message, and I will talk to you soon. Have a great day, guys.